Hey everyone, welcome to another session of Global Hack Week. Today I will be your host and I will be basically guiding you through this awesome day of getting started with Arduino. I know this is the first day of Global Hack Week, Beginners Week. This is usually one of the weeks where we get, a lot of beginner hacks. So we try to make all of our streams beginner focused, but if you know my streams, you know that I always like to make them from scratch and make them available for everyone that wants to join without like having anything from context before. I shared a link on the chat in there. Please feel free to check in. It is very important that you check in because we have a point system, and depending on how many points you get to earn like some basic swag. So make sure that you make your attendance on this stream count by checking in into this link. Um, Great. So again, my name is Jocelyn. I will be your streamer during this Global Hack Week. I'm also a coach at Major League Hacking. Actually, this month I will be traveling each weekend to a different event. So I'm gonna go to Montreal, then I'm gonna go to College Station, and then I'm gonna go to Toronto, and then I'm gonna go back to Houston. So it's gonna be a really packed month of full of events. If you are gonna be at any of those events, feel free to let me know so we can connect there. Some of the things that I like to do, I like salsa dancing, and I also like to collect Minecraft bee plushies. Unfortunately, I don't have any bee plushie right now in here as I usually show you during stream. But I will have more soon when I get new ones or I go back to my usual place. And yeah, if you have any questions throughout the stream or you just want to have a side conversation about something or any topic that you would like to talk about, feel free to drop it in the chat so we can talk and have our little side conversations, which are usually things that I really enjoy doing. All right, so for today, we actually have a decent amount of content. There's some times where I really have to rush myself to get to like every specific point. But for today, as we are seeing basics of Arduino, so nothing too complex. We're just gonna go over the basic pins on the board. We're gonna see other variety of boards, so you know that Arduino is not the only thing for making hardware. We're going to use a simulator, online simulator called Walkwe, and we're also going to be using Tinkercad. But we'll see if I can show you both simulators, and then you can stick to whatever you feel it's more comfortable for you. And at the end, we're going to learn to code different components. I think I'm going to stick with the regular LED. We're also going to be seeing DC motors, and we're also going to be seeing ultrasonic sensors. There's a whole different variety of components. We're also going to mention them, but the ones that we're going to be actually testing are the ones that I just mentioned. And my goal after this session is that you will have a live Arduino simulation. Again, if you are someone that really knows how to use Arduino boards and are very experienced with hardware, these tools will also be helpful for you because you will see that there's more boards that you can use on those online simulators. And I will also be making like small parentheses during my explanations for more experienced hackers if they wanna jump in. This is my first set of streams related to hardware. I will have more further on during Beginners Week. So I know tomorrow I will only be giving the Today in Global Hack Week, but then I believe that on day 3 I will be teaching PID controllers on learning how to make your robot self-balance. So we're going to learn the math, we're going to see a bit of code, and I'm going to see if I can do an online simulation so you can also see how it actually works in industry. And this is a concept that you will have to learn if you want to get into robotics. What do I need to install in order to follow up with you? There's nothing that you need to install. We're going to be using an online simulator. I'm going to be sharing you the link further along, and I will also give you some time for you to create your accounts so we can all be on the same page. Great. So without further ado, I will start with the first section. So Arduino is just basically a board. It's a physical hardware that you get to use, and an important thing to know it's completely open source platform. So it means that developers around the world can actually contribute to the Arduino project. Arduino refers to two things. We are talking about the hardware, so the actual board that's on screen, but we are also talking about the software IDE program used to use it. So if you want to program in Arduino, like the actual physical hardware, you will need one of these boards and you will need to download the application. We're not going to be doing that today because we are not going to be using like physical hardware. We're going to be using simulator hardware, but I can go into the page in a couple minutes and show you what I'm talking about. This microcontroller it's very beginner friendly. It's one of the microcontrollers that I recommend to hackers that ask me about getting started with hardware or learning about robotics. If you get to master Arduino, you will be able to move further along into more complex pieces of hardware that require a bit of higher understanding. Why? Because Arduino is designed specifically for beginners, and it makes everything like so simple. In order, if you learn how to plug in like a couple stuff of components, and you will be basically able to plug in and code anything that you can imagine. Anything that you can imagine. Um, Okay, so as any other microcontroller, it has specific pins and it also has its specific distribution. I wish I could have one with me right now so I can show you like physically what it looks like. If I was in my home, I can definitely do that, but right now I basically don't have any of my belongings with me. But hopefully this image is clear enough for you to see how the distribution is organized. So we have three main categories of pins. So we have the power pins, supply voltage. So voltage, everything related with 5V, 3.3 volts or voltage in, and ground. So if you know a bit about circuits and electronics, you know that you need your you need your power and you need your ground. So those pins are located in the lower side where it says power and ground. So on the actual board, and you will see a bit better once we start running the simulation, you will see that it says like 5V, 3.3V, ground, and some other pins that we're not going to be focusing on. Why do we want to have a pin that's 5B and another that's 3.3B? Because there's some components that can only receive a certain amount of voltage. Let's say that we are, I don't know, we are using like an LED. We can use a 3.3 voltage pin because we don't need like the actual 5 volts in order to run like everything. Usually you can see the descriptor sheet of each component to see how many voltage you can apply to that specific component. And according to that documentation, it's whether in which side you're going to plug it in. Then we have the digital input and output pins. These ones can be set up as input or output. So either you read stuff from it or you write stuff in it. Some even support PWM signals. I know that if you are just getting started with Arduino, maybe this term of PWM might be a bit confusing. I will explain these when we see the motors in a while. But for now, you just need to know that the digital pins are up here and you can see like their names, let's say 0, 1, 2, 3, 4, 5, up to 13. And the ones that have this sign that's like a curved line are the pins that support PWM signals. Finally, in here on the lower end, we have the analog input pins, and this one read analog signals from all the way from A0 to A5 using a DC. Okay, so before I move on into the next slides where I will be explaining like the difference between power pins, digital pins, and analog pins, is there any hacker in the chat that can tell me the difference between a digital pin and an analog pin? I will give you a couple of seconds for you to type that answer in the chat on what's the difference between a digital and an analog pin, to see how the audience is like located right now and see if I should go a bit more faster or just slow down and explain things a bit more clearly. So again, the question is if any hackers knows the difference between a digital pin and an analog pin on an Arduino microcontroller. And I will see your questions. Okay, so we have an answer in here. Digital can only give a Boolean. Yes, that's actually going towards the right direction. No worries, we're just gonna learn about it. Okay, so if we move on, this one is about the Arduino power pins and the supply voltage, the ones that are down here. If you see, it has a label saying power. 5B, it's regulated 5E, and you actually have two of those. Then we have the 3.3 voltage pin. That's for components that need less voltage in order to be powered. And then we have the V in pin, which is basically input voltage. If you wanna like power your Arduino externally, let's say that you wanna like control bigger motors that require higher amounts of voltage that the Arduino cannot supply, then you will need to plug in like a battery throughout a voltage regulator in the B in pin. And finally, we have the ground pins. I believe there's two of them in here, and there's another one on the upper side of the Arduino. Ground pins are just like ground. It's basically like the black cable that you connect for all of your components. I know that by now it might be a bit blurry explaining like ground pins and voltage pins, but once that we start seeing the components, you will realize like, oh, like every component needs to be plugged into power and needs to be plugged into ground. Otherwise, like it's just not gonna work. Um, and then we have the digital input and output pins and how they actually work. So there's tons of them in here. For this specifically, a hacker really mentioned like something important, that it only gives like Boolean values, and this is true because digital input and output pins, they can only read signals, well, digital signals that are high or low from either a sensor or a switch, which means that you can only have like 0 or 1 values. So if you want to see an example of these, like an LED, right? So you can only turn on and off your LED. Let's see what else, like a switch, you can only turn it on and off, and those are examples of digital pins. So you can only think of a component that has two states, either on and off, and you have to plug those components in the specific digital pins. And then the pins that are marked with this PWM signal, those are the ones that can simulate an analog output using what's called PWM. That's related to motor controllers. We're going to touch base on that a bit further in the presentation. But for now, you should know that if you want to plug a component or read stuff from a component that's digital, so two states, you want to plug them into these pins that are over here. Great. And then finally, we have the analog input pins. The analog input pins are less, and they're down here where it says analog in, labeled A0 through A5. These ones are talking about signals that change values. So if you are reading like values from like a color sensor, or you want to control like a potentiometer, or like the brightness of a LED, where you can actually adjust the brightness. Because if you plug like an analog device into your digital device, you won't be able to control it because you can only send like high or low. And in the analog input pins, you can actually send values like 255, 215, 20, 25, like, random values. Well, not random values, but like numbers that change. That's not only like 0 or 1. So if you were to plug your motor into the digital pins, you can only turn your motor on and off. But if you plug your motor into the analog input, then you can change its PWM signal to be like 255, which is the maximum speed that you can get from the motor. These pins are used specifically for sensors like, as I was mentioning, potentiometers, temperature sensors, or even light sensors. And yes, they can also function as digital input and output pins, because at the end, if you're only reading like a 0 or 1 value, like your analog input pins will actually like allow you to do that. I know by now it might be a bit confusing to like understand like the difference between these two types of pins, but I promise you that when we start doing like the code and the actual project, you will make more sense of what I'm talking about, that you can only receive specific like types of values. Great. So as right now we were talking about this specific board that's called Arduino Uno, which is the basic one, but there are more boards out there. So you can find another different boards that you can use for specific pins, like bigger boards or smaller boards, or boards that support Bluetooth or Wi-Fi or other types of connections that you would like to use. So it's not only that single board that we have in here. So there's definitely more out there that you can use. And then I also want to make like a small emphasis in here, saying that Arduino is not the only microcontroller that you can use. There's other microcontrollers out there that you can actually code and you can do like more advanced stuff. But Arduino is really nice for getting started and you can do a simple projects, but you can also do like really complex projects if you know how to connect like different Arduinos together, or you want to work with different stuff. And yes, there's a hacker in here saying there's also Raspberry Pi. Yes, that's also another thing that you can use to code. Raspberry Pis that actually work a bit more like small computers, because you can actually have operative systems running in your Raspberry Pis. And in Arduino, you wouldn't be able to handle that because Arduino is just a microcontroller and it only runs a single piece of code simultaneously. So it only has like a single designated job that it will perform. And the Raspberry Pis, they can do like different types of jobs like at the same time. So they're a bit more advanced and you can use it for more like heavy processing if you would like to see it that way. Okay, so now let's move on to our project part. We're gonna be doing something simple right now. So I'm gonna be sharing the link of the platform that we're gonna be using. That's called Wokwi. Let me see it in here. ESP32 or something like that can be an appropriate example. Yes, that's another type of board that's used, especially if you want to do like IoT projects. That's your go-to microcontroller. Great, so we're gonna be entering this page called Wokwi, and we're gonna be doing a simple code and a simple, example in there. And I'm just gonna give you a couple of minutes for you to create an account, and then I will start sharing my screen where you will be able to see like what we're gonna be doing today. I'm just gonna give you a couple of seconds for you to see that. All right, so I'm just gonna go through this slide first. I'm gonna be explaining this component. I know it's a super basic component, so for the people that already know what this is, I know it's just an LED. It's a small bulb of light that turns on and off. LEDs are basically components that you can use if you want to have like a flashing light on your car or on your robot. I would say it's a component that you get started when you want to like try something out. It's like the simplest thing that you can try on. And we're actually going to be using this as an example to get us to know the environment in Wokwi, which is the simulation platform that we're going to be using. So to connect an LED into your Arduino, it has two, how do you call this in English? Two legs. So you have your cathode and you have your anode. So in the anode, you're gonna plug in a resistor. So if you already saw basic electronic course in your either high school or university, resistors are just basically components that you want to use in order to reduce the amount of voltage that goes through this current in here. So let's say we do these with the purpose of not burning the LED because they can only receive a specific amount of voltage. So by using a resistor, we are like reducing the amount of voltage that goes into our LED, making it work like seamlessly. In here, the recommended resistor that you can use is 220 ohms. but you can also use like different amounts. I mean, it doesn't have to be specifically 220, and you can even turn your LED on without the resistor, but it will probably burn in a couple of minutes if you leave it on for a really long time. And this anode is the one that you connect into your digital pin, because again, we want to connect it into our digital pin because we can only turn it on or off. And the other leg, it's nothing too complicated. You just connect it to ground, and then that's it. Yeah, so this is basically like the circuit that we're gonna be doing. I think we can see it in here. Um, I don't want to go really too in depth on how breadboards work, so I'm just going to skip this slide and then I'm going to go directly into this one. So instead of having like your components floating around and just like connecting them or soldering them, we use these devices. Well, they're not devices; they're mostly like tools or like a component. It's called a breadboard. This white rectangle that's in here, and you can use your breadboard like a map for your circuit, and it allows you to plug things like really easily, so you can have like all of your circuits in there instead of just having them laying around on your table, which will make them a bit more messy. So for breadboards, there's nothing too complicated. If you see, we have like a red line in here, and we also have like a blue line. I'm gonna go back in here. Um, so for the blue line, that's ground, and then for the red line, that's voltage. So if you see, the Arduino is giving power into our breadboard in the ground line, which is the blue one. And then on the voltage one, we are just going directly for the LED in this leg, and then this one is connected to the resistor, and the resistor is connected to ground into our Arduino. And if we are seeing in here, our LEDs plug in into the digital pin number 13. So we're gonna be replicating this circuit into our walkway example. So I'm just gonna be removing these and then showing you how it looks like. Okay, so here we are. Hopefully you should all be in this page in here. We're gonna, as I was saying, there's different components that you can use. ESP32, there's the Raspberry Pi Pico, and then there's the STM32, which is this one is like super powerful and it's really cool. I think I've done a couple of streams using this one in more advanced streams, but I can definitely show you a couple of projects at the end if we have time. Great. So for the Arduino Uno, you're just gonna select it in there, and then we're just gonna slide down, and we're gonna start from scratch. If you see, there's different Arduinos that you can pick from. Arduino Mega is basically the same as an Arduino, but it's just bigger. Like it has capacity for more pins. And then the Arduino Nano is same thing, just smaller. So for like smaller robots, or if you don't wanna have like a super big board, you use an Arduino Nano in there. So we're gonna go with the Arduino Uno one. So I'm just gonna select it, and then we have our board in here. So if you see, we are able to see all of the pins, and if we hover like slowly in here, you can see like what it's on each of them. We have our digital pins in here, 0 through 13. We have our analog pins in here, and then we have our power pins in here that says B in, ground, ground, and then we have 5B, 3.3B. Great. So I'm gonna make this, I don't know if I can make it smaller. Not so sure. Oh, there it is. You have a question. Could you please show what you selected again? Yeah, for sure. So if I go back in here, yeah, I'm just gonna leave. So this is the main page where you're gonna be in, and then you're just gonna have to click on Arduino, go all the way down, and then select Arduino Uno. And then you should be seeing exactly the same thing that I'm seeing right now. Great. So what we're going to do is that we're going to be adding all of the components that we were talking about. So we have the main component, which is the LED. So you're going to click on this button that says like the plus sign, and then we're going to add the LED. So I'm just going to place it in here. There we go. And if we hover in here, we will see that it says an A, and then we have a C. So A corresponds to anode, and then C corresponds to cathode. For this first example, I'm not going to be using the breadboard because it's like digital. It's a simulation, so it doesn't matter if it gets messy. But I will add it on the next circuit so we can add a bit more complexity, and you can also see how it actually works, like with everything that's in there. Great, so we're gonna first connect our cathode, which is the one that we saw. So we have this one in here, and this one goes directly plugged into ground. So you're just gonna grab this leg and you're gonna plug it in here where it says ground. It doesn't matter which ground pin you choose. It can be either this one, or this one over here. So it really doesn't matter. And for just aesthetic purposes, I'm just gonna change these to color black so you know that this one is the ground pin that we have in here. And then for the anode, we need a resistor. So I'm just gonna click on the plus part and I'm gonna pick the resistor. I'm gonna the value, I'm gonna change these instead of being kilo ohms, I'm gonna change it to ohms, and the recommended value is 220. So as we are using like a simulation, you can control everything. But if you were like in an actual lab where you don't have all of the components that you want, then it might get tricky to look for these components. So let me just move these like this. Okay, and then this one, oh, I hate that this appears. Okay, I'm just gonna grab the other leg and I'm gonna go all the way over here, plug it into the resistor. And then for this one, I'm just gonna, why is this appearing? I'm just gonna select any digital pin in here that I want. So I'm just gonna select like number 7 because it's my lucky number. So 7. And I want to change the cable to color red, so you know that this one is our is the one that's supplying power in there. Great. So with this, we are completing our circuit. So now what we have to do is that we need to do the actual code for these. So for Arduino, I think I didn't like organize a slide for these. I should have done that, but I will just explain it on the run. So you have your void setup, which is where you have to declare like all of the pins and all of the things that you want to declare first, like your variables and all of that stuff. And then on the loop is a thing, you can see these as a while loop that's just going on and on forever, and it doesn't stop until you disconnect the program. So on the setup, we will hopefully have all of the declaration of our pins. So either digital pins, analog pins, or objects that we're gonna be using for components. And then on the loop is where the actual like logic for your circuit goes. So in this case, the first thing that we're gonna be doing is that we need to declare a constant for the name of the pin that we are using. So we are using digital pin number 7. So I'm just gonna do const int because 7 is an integer. So we wanna be, our pin is an integer. I'm gonna call this let pin and it's equal to 7. Another important thing to note, Arduino is basically C++. So all of the C++ things will work here. The only difference is that you have specific things that are from the Arduino like environment. For example, in our setup, what we want to do is that we want to declare our pin mode. And pin mode receives 2 things. It receives the name of the pin and either if you want it to be an input or output. So in this case, our pin is called LED pin. And then we want these to be an output, right? Because we are going to be outputting like the light that turns on and off. And if you see in here, we can actually select from the 3 options that we have. So I'm just going to select this one as output. And that's all that we need in order to declare our LED. And then the loop code, where we're going to be running our main code in here repeatedly, we're going to do digital write. If you were going to read values, you will be using digital write. But as I'm going to be writing a value, so I'm going to be writing either on or off, I'm going to be using the digital write. And then this one as well receives two things. It receives the pin, so let pin, and it receives a state. In this case, it can either be high or low. In my case, we are going to be using high because we want to turn our LED on. And that's it. So I'm just going to save this project. I'm just going to call it basic LED, so we can actually like run the project. And then I'm just gonna click on play in here. And there we go. We are seeing our LED turning on in here. Again, I'm going to go over basic things. So you will be needing to declare your LED pin, which is this one. Then our setting up. So pin mode, we want to declare if it's either an input pin or an output pin. In this case, it's an output pin because we are outputting some light in here. And then the thing that's going to be running repetitively goes inside the loop. So we're going to be writing a digital value in this pin, which is pin number 7. And we want to turn our LED on. So let's say that we want to make our LED blink. What we will need to do is add a delay in here. So I don't know, 200 milliseconds. And then I'm going to do digital write again. We're going to be doing let pin. And now we're going to be changing this to low. And then I'm going to be adding the delay again so you can see like the effect of blinking. Let me save these, stop this, and then run it again. And then if you see, our LED is basically like blinking like on and off, and it goes and goes and goes. Great. So any questions about these before we move on to the other ones? I can also give you a couple of minutes for you to finish this example. I think I'm actually going to be doing that. I'm going to be giving you about 5 minutes for you to replicate this into your environment so you can get a bit of, like exploring how it works. You have the code in here and you have the circuit in here. So basically you have everything that you need in there. And yeah, I will be giving you that time, and then I will come back and we will be seeing the two other components that we have pending into our agenda. Great. So hopefully that was enough time for you to finish your circuit and also explore the platform so you can get a bit used to on how it actually works. So I'm seeing a couple of questions in here just after we gave this short break. Could you explain the functions, like quickly go through behind the scenes? Yes, I'm more than happy to do that. You know what? I'm just gonna finish the other components that we have pending, and then I'm gonna show you how that works because it's like having a huge sideline, and then I will get too excited talking about that I might just not end like the actual content of the stream. But I really appreciate that you are, interested on how it works. And yeah, definitely these functions have more things that happen like behind the scenes, and I'm more than happy to explain that just when we finish the components that we have pending. Great. So clicking to connect is so complex. Yes, I know. I was struggling myself because I think you have to click it once and then like actually drag like the line in there in order to make it work. Hey there, happy to see you in here. Really excited about your first stream as well. We have an error in here, build failed. Let p does not name a type. Const let p. I think your error is that you are missing the int in here. You're only declaring the constant and the name of the pin, but you're not declaring the type, which is the integer. So make sure that you add your int in there. Yep. Awesome. Great. So let us know if that was the issue. If not, we are more than happy to help you out. Great. So now that you were able to run this simulation, let me know if you are having more issues in general. I'm going to move over in here so we can see what's next. So now we're going to be seeing a couple components that I have to say there's like the most, the ones that we use the most. So we're going to be seeing the DC yellow motors. We're also going to be using the motor controllers, and we're going to be seeing the ultrasonic sensor. So for the DC yellow motor, I'm going to be jumping into another simulation platform. And then for the motor controller, I'm just going to show you a couple images of how it works. And for the ultrasonic sensor, we're going to be doing it on Walkway, which is the same simulator that we have. Why? Because fortunately, Walkway does not have the yellow motors or the motor controllers that we want to use. But I'm more than happy to show you like the circuit of how you can actually connect it into something. And I'm just going to be replicating the example for the ultrasonic sensor, which is the one that we're going to be doing. Great. Really happy to know that it's working now. All right, so now it's time to talk a bit about how motors work and now getting to the signal that I was talking earlier, the digital PWM signal. So the yellow motors, as most Arduino people know them, they are direct current motors. It's a common beginner component for beginners. They are used as motors for like robots. If you want to make like a small car or just make something with wheels, it's your perfect choice. And for the motors, you can plug them in directly into your Arduino, but you will not have control of you will not have control of how fast like they are spinning. Because if you see, they only have two cables in here. So they only have the signal cable, or well, the power cable, which is the red one, and the black cable, which is the black one. That's the ground one, my bad. So if you plug in those directly into your Arduino, they will turn on, but they just, they will be spinning randomly. And you want to use a motor driver, which is this thing in the middle. And the motor driver will allow you to actually drive the motor. So tell you like direction and also how fast you want it to go. So yeah, if you just want to turn your motors on to test them, you can plug them in directly into your Arduino or even directly to your power supply. And then if you want to control speed and it's not speed, it's your PWM signal, you will be needing to use a motor driver. Okay, so this is how actually the motor controller works. It's basically an H-bridge design for two motors. So on your motor controller, you can plug in two different motors, and you can handle high current voltage for motors. This basically control direction and speed, which is your PWM signal. I think I did not include an image of these, but I am happy to look it up online and show you how this signal works, and also the motor controller so you can see it. Um, and yeah, I think this circuit is a bit complex, so I'm just gonna jump into like looking it up directly online. So I'm just gonna look motor controller, yellow motor. Um, okay, so this one is really a decent one. So let me just zoom in. Okay, so hopefully you should be able to see everything. So this is a motor controller. Is the one that you can find at any student electronics store. You have your motor in here, and if you can see, this one has like your ground one, and you have your voltage one. So you just plug them in into these boxes in here. And then you will have your other motor if you would like in here. In this case, they're not using this one, but you can control two motors at the same time. Then you have your input one and input two. These ones are the ones that actually control like the speed of your motor. And then we have these three boxes in here. We have the 5B that goes directly into your Arduino, the ground, or your 12B in case that you want to supply it with external power. So I know there's many cables in here, but it's just a circuit, so you can plug these exactly on your actual hardware and it will work. So plugging the legs of the motor in here, then this one into your pins in here, and then your ground and 5 voltage and 12V in case that you need it. Let's see if we can find a real example. Here's like an actual picture of how it works. Let me see if there's another one. Okay, this one's actually really decent. So motor connections in here. So the blue boxes in here. Then you have your pins in here that are the input pins that you can use, enable A and enable B. You have ground and the power voltage. And if you see here, the ground should be a common ground with Arduino and power supply. So this one should be plugged in directly into your Arduino. Let's see if there's another one. Okay, here's a dual one that connects basically everything. And the name of the controller, it's called L298N. So that's how it's called. And here again, we have our two motors. So motor A, we have positive and negative. Motor B, positive and negative. Then we have our enables and our inputs. And if you're seeing, the NA corresponds to motor A, and then NB corresponds to motor B. And if you follow these cables, you will see that these ones are plugged in into digital pins that allow PWM signals, because it has like the line that goes like this. So you are able to write PWM signals in there. And then we have the input, and in 1 and in 2 and in 3 and in 4, which are just for control of the motors. And these ones, they go directly into any pin, any digital pin. It doesn't matter if it's a PWM or not. The only ones that you care that are PWM are the NA and the NB in here. And then we have the external power supply in case that you need it. So we have the 12B in this case, that is this set of 3.7 batteries. And then we have the ground. And if you see, there's a common ground in here on your Arduino. So there's the G and D in here. And this one, it's also supplying voltage in here on the 5B for these joystick. And then the V in that's receiving external voltage is the one that goes to the batteries in here. So you can basically control everything. So this might look like a more complex circuit, but I promise you that this is basically the standard. So when you're building like a project that is related to a car or something that has two wheels, you will always be needing these motor controller in here and your basic motors. You can change the motors. I mean, they don't have to be exactly like the yellow ones are the ones that I'm talking about. So if you see Arduino, so these ones are the basic ones that you can find online, and they come with a wheel in here. But if you see these motors, they can only spin, but they don't have any encoders, so you can't actually track and like measures stuff. On the stream that I will be giving, so this one, I will be showing you how to use an encoder on your robot, so you can teach your robot how to balance and regulate speed according to your actual error. But yeah, this one are the basic yellow motors. Hopefully, it was enough for you to see like the diagram and how it actually works. Sadly, this one they don't have like, I think they don't even have motors in here. Yeah, they don't. But I believe in Tinkercad they do. It's not necessary for you to go in here. This is just another platform that you can use in order to build your circuits. From my personal experience, I prefer to use Walkly, not for Arduino, but for other controllers that I will show at the end. In Tinkercad, you can do different stuff. There's a couple of projects in here that I've done. And if you click on create, you can either design a 3D design like CAD circuits, or even code blocks like Scratch. So if you go into the circuits one, I'm not going to be going more in depth in here, but if you see, there's more variety of components in here. So if you go to all components, you should be able to see like all of the components that are in here. There's plenty in there. So this is the one that I'm talking about, the basic motor that we have in here, have negative and positive. And let me see, there's even a lemon battery, that's crazy. So I'm gonna just, so you can see, I'm just gonna plug in like a battery in here. Let me see if I can. This is fun. Okay. So positive and positive. And then we have negative and negative. And start simulation. So if you see, not very clearly, but this is like turning around because I just plugged in into my battery. But this is not very helpful if you were like controlling your robot, because it will only be moving like at a specific pace. So in order to fix that, you will need to be using your motor controller in order to regulate your PWM signal. So I know that I've talked a lot about PWM signal, but I haven't shown you how it actually looks like. So let's just see how that looks like. This is not what I was hoping for. Okay, this one's actually fair. This one's actually fair. So for PWM signals, because I know that it's on a digital pin, so it can only be like on and off. How it works is that there's different pulses, right? So you can actually regulate your pulses depending if you apply a specific amount of voltage and in a specific amount of time, which is your period in here. So that's why you can get your frequency, and you can also get your duty cycle, which is the time that your motor is on divided by the amount of time that you left like that period on. And it looks like this. It's just like pulses that go on, and this is the actual input that the motor is actually like interpreting. So for Arduino, it's very simple. So you just give it like a digital write, and then give it the amount of PWM that you want your motors to go on. But when you talk about different controllers that are like on the backside, there's a lot of clocks and things that go in there in order to reproduce this signal that you are seeing in here specifically. Great. So I'm just gonna stop this one. All right, so I guess we can move on to the other one. Let me remove this one. Does it relate to how real motors cars are made as per bigger components? Yes, exactly. So this is how your actual car like works at a bigger scale. Arduino is just an introduction to that world. But when you start learning a lot about microcontrollers and hardware, you will see that there's always something else that you need to learn about. So, for example, right now we were talking about oh, sorry. We were talking about, for example, declaring your pin in here. So in Arduino, you're only seeing this function that's called pin mode. You input the LED pin and you declare this as output. But for actual controllers that are used on industries, it's not that easy to just say like, oh, I want this to be a number 7 and I want it to be an output. So there's a lot of things that you need to configure on the back of that function in order for it to be an output pin. At the end, I'm going to show you an example of how to do this declaration, but in hard mode, like in bare C code, so you can see it. And yeah, but I wouldn't say, I just don't want to overwhelm you with everything that's like inside of all of these functions. And all I would say, first get the basics, learn everything, get really comfortable with Arduino, and once that you master Arduino and you have no struggle at all in plugging components and changing the code and playing around with the logic, then you can move on to other different components, and it will also be easier for you to understand. And once you go back to Arduino, you will realize like how things have changed in there. I think I have made streams about embedded systems where I show like how the boards work. I think they are in another edition of Global Hack Week. I really don't remember which one they were, but I always make I always like to make streams about hardware, so I will definitely be making a bit more. Okay, so we're gonna be moving to our other component, and this one we're actually be coding like all of the code, and we're also gonna be doing the circuit into our thingy in here. So ultrasonic sensor, it's a sensor that emits sound waves, as it's called, and we can use these to measure distance between objects that you are seeing. So if we're talking about an autonomous car and we wanted to avoid obstacles, then we can use an ultrasonic sensor in order to detect that obstacle and see how far our obstacle is. So how it actually works is that the ultrasonic sensor, it emits a signal, and that signal goes like straight, and if it crashes with something, it will like bounce back, and then you can actually measure the time that it takes for that bounce to happen. And as we have time and we have the distance that we have, you can actually calculate your distance in centimeters using speed of sound. I know it might sound a bit blurry, like, oh, measuring like the speed of sound and getting our distance. But yeah, that's just basically, oh, okay, so actually a hacker just gave us like how it works. So you are completely correct. It's nothing more than just measuring that. And if you were like to block your sensor, you would see that it intercepts that signal, so you're able to measure like the distance between the sensor and like any other object that you have. That's why in this image we are seeing the ultrasonic sensor and we see like a wooden block in there, and then we see like the signal that's coming in and then the signal that's being bounced off. And yeah, you can measure the time between the one that's being emitted and the one that's being echoed, or I don't know how to pronounce that. Okay, so I guess let's go into our walkway in order to code this. And we can actually look the circuit up. So if sometimes you forget how to plug something, or you just want to look for inspiration, you can always check like ultrasonic sensor and then like circuit. But before doing that, I'm just gonna, I don't know if it's, I'm just gonna create a new project. I think that's easier. So I'm just gonna create a new project to start from scratch. I'm gonna add my ultrasonic sensor, which is this one. It also has like a fancy name, like HCSR04. That's the actual name of the component. So if you see in here, this one has, I just want to zoom in. Okay, I'm not sure if you're seeing these like good enough. Okay, that was weird. Okay, so we have different pins in here. We have our voltage, which is BCC. This one goes to 3.3. And then we have ground, which goes to ground on our Arduino in here. Then we have our trigger, and then we have our echo in here. And these two go to two digital pins that are the ones that are in here. So I'm gonna zoom out again. And let's plug everything. So BCC, this one, you are going to connect it into your 3.3 in here. There we go. And then ground, we're gonna plug that into ground. There we go. And then the trigger one, you will plug it into any digital pin of your choice. So I'm choosing 7. And then I'm going to be choosing one over here so I don't mix them up. So 7 and 8. There we go. So we have our two digital pins in here for trigger and echo. And then we have BCC and ground in there. Awesome. So I want to give you a couple of seconds for you to plug everything. And then I'm just going to move on with the next section. Let me know if you have any questions as well. I don't think we have much things pending, so we just have ultrasonic sensor, make sure that it works. And then I'm going to show you a couple of projects and other components that we can use. Could you please repeat again? Yes, right now, what we have done is connect our ultrasonic sensor. So you're just gonna click on the arrow and then look for ultrasonic, and you should be seeing this one. You're gonna click on that one, and then you're just gonna plug in like all of the legs that are in here. So BCC, the red one goes to 3.3. Then ground, the black one goes to GND, which is ground on the Arduino. And then these two, you can connect it to any of these pins that are in here. And I'm just giving you a couple of minutes for you to finish plugging all of those wires, which I know might be a bit tricky sometimes. And so I can move on into the coding section. All right, so I guess we are good to go. Okay, I guess we are good to go. Please pause me if you have any questions while I'm doing the code. This code is a bit longer because there's a bit more logic that we're gonna be doing, but hopefully it's good enough for you into seeing like the pattern that all Arduino components follow. Okay, so as we did with our LED, we need to declare the pins that we are going to be using. In this case, we have two pins, two digital pins. So we have the 8 and the 7. So again, I'm going to declare two variables. The first one is going to be my trigger pin, which is on number 7. So trigger pin, and that one is going to be equal to 7, right? Right, and then I'm just gonna create another variable, const int, and this one is gonna be the echo pin. And if you see, the echo pin goes directly into 8. So echo pin equals to 8. Right, so just declare your two digital pins in there. We have a question. Is it okay to draw the line overlap with other lines? Yes, that's fine, as long as you don't see that there's an intersection between them. So if they cross over like these, it's okay. But if you see that there's like a small dot between them, that means that they're intersecting. Like for example, right now mine are going like over, but it's completely okay because there's no, I mean, there's a visual intersection, but I don't see like an actual dot in there. That means that it's connected. So it's completely fine if they run over like these. All right, so declare your two pins. And now that we've done that, we also we're going to go into our setup in order to set up our ultrasonic sensor the same way that we did with our LED. As we have two pins, we need to set up two things. So we need to set up the output and the input. So trigger pin is the output, and then the echo pin, which is this one, is the input. So as we did with the LED, we're gonna be using pin mode, and then we're gonna be adding trigger pin in here. And this one is gonna be our output. So I'm gonna select output, and then I'm gonna do the same for the echo one. So pin mode, and then echo pin, and this one's gonna be input. All right, so now we declared the same way that we did with our LED thing. We have another question. Does it matter where the trigger and echo pins are placed? Nope, it's completely up to you, as long as you make sure that you select that you place the correct number in here. Like if you plug the trigger in number 13, make sure that you change these to 13. Other than that, it's completely fine and up to you. My trigger pin was 8 and my echo was 7, the opposite of yours. That might be a bit confusing for you, but it's completely fine as long as you make sure that the variables are declared correctly. Great, looks like you're all on a good track. All right, so the next thing that we're gonna be doing is doing the actual logic for the loop. And this one is a bit more complex, but not so much, and you will see why, than the LED. So as we're saying, we want to use our trigger pin in order to produce an output, which is the signal that we're going to be emitting into our object, and we want to measure that distance. So the first thing that we're going to be doing is that we're going to be clearing the trigger pin. Then we're going to be setting our trigger pin to high state, and then we're going to be reading our echo pin so we can see the sound wave that's returning in microseconds. And we're going to be using the formula that a hacker shared in order to calculate the speed of sound in the air, which is actually a number that I don't remember, and I will have to look up. And then at the end, we're just going to print like our values. So again, the first thing that we're going to be doing is clearing, let me type this in, clearing the trigger pin. And to do that, it's just setting it to low. So again, as we did with our LED, digital write, and then trigger pin, and setting these to low. And we're gonna add a small delay in microseconds in here. So we're just gonna do like, I don't know, like 3 microseconds. It really doesn't matter. It can be, it's just so we can add like a small delay to make sure that this happens and it doesn't go like immediately to the next instruction. Because in this code, instructions are executed line by line. So if I do this one and then I do the other one, it will be like immediately at the same time, and maybe it won't have enough time to process this one. So I want to make sure that we add a small delay in here. Then the next thing that I'm going to do is that I'm going to set the trigger pin to high for a time to send the wave. Okay, so set the trigger to high, so we know how to do that. So that's a digital write again. It's trigger pin, but this time we're gonna do it high, and we're gonna be adding a delay. In this section is where we are actually sending the sound wave that is the one that's gonna be traveling. So the delay is gonna be a bit bigger, so 10 microseconds, and then I'm gonna shut this down. So digital write and trigger pin to low. And wait, I forgot to do trigger pin here. Okay, and now that we finished with the trigger pin, we're gonna measure using our echo pin. And the echo pin, if we see in here, this one is set up as input, so you can actually like read from there. So for the echo pin, we wanna return. So we want to read like the sound wave that travels in microseconds. So for that, we actually want to equal that value into a variable. So I'm going to be creating a variable in here called int distance, and then equals 0. And then I'm going to use that one in here. So my distance is going to be equal to pulse in. So the pulse of my, and you can actually see let me see what it receives. Can I see that? I think I cannot see that. But it receives the same. So it receives like the pin and the state. So we're receiving the echo pin, and we know that this one is going to be high. And then once that we have our distance stored in here, we can actually calculate that using the formula. So distance is equal. Wait, no, this one's not distance. This one's the duration. So I need to create a new variable, int duration equal to 0. Yeah, because this is the amount of time that our wave lasted. So to go like one way and back, and then we actually want to use the duration in order to calculate the distance. So for that, we do duration and we multiply that by a constant that I don't know and I need to look for. So constant divided by 2. So let's look up for that constant. Ultrasonic sensor constant for distance. Okay, that should do, but in centimeters. So 0.034. Okay, so constant used for calculating distance with an ultrasonic sensor is the speed of sound in air, which is approximately 343 meters, which is time, speed of sound divided by 2. This is the exact same formula that we're trying to use. So let me just, I will copy paste this in here so you can see it a bit clear what I'm trying to do in here. So we have time, and then our constant is 0.0343, I think so, divided by 2. So this is a constant divided by 2. So with that, we will be getting the distance of the sound wave that we just sent. And then at the end, we're just going to print our stuff in here. So serial.print. We have our distance in here, and then we're just going to add distance. All right. And then I'm going to add a small delay so we make sure that we are printing everything smoothly. And one thing to note in here is that delays are not good for your hardware. They are definitely not good, but we are learning, so we're going to be using delays. And the reason why they're not good is because delays actually freeze everything up on your code. So let's say that we are, I don't know, we are building a robot where you have to have like an ultrasonic sensor, but then you also want to have your motors spinning. So if you do a delay, you will like slow everything up. So your whole system will freeze for 100 milliseconds in there, and your motors will also not be running properly. So basically delays screw up everything in your code. But if you're only testing like an individual component, then it's totally fine because you only have one thing running, so it's okay. Other than that, feel free to use them, but understand that there's repercussions of using delays on your code, and if it starts working unexpectedly, it is mostly related to the delays that you have in your code. There's an alternative. Instead of using delays, you can measure the microseconds in time instead of actually using like the delay of the whole system. So like alternative. And this is actually how like professional code is done, like how to use millis instead of delay. As we're saying, the delay function is a blocking function. It can cause some issues such as prevents executing other code, makes external events be missed, and makes it difficult for other timings. Fortunately, we can use millis instead of delays, and this is how we use it. Delays, and then you will have to do this code. We're not going to be doing these, but I just wanted to understand that this is not like the standard, but it's like a faster way to get there, if you know what I mean. All right, so let's test this up, and I don't know how I'm actually going to be placing like an object in here, but I guess we'll find out. Inflection by loop, I respected. Oh, I forgot a semicolon here. Ultrasonic basic. All right, so let's run these. I'm supposed to be seeing like the. Oh, okay. Editing ultrasonic distance, and I can see. But where's my serial terminal? Should pop up in here, and I'm not seeing that. Serial print. I'm doing that. Hmm. Let me see if there's a way of triggering that. Restart simulation. The book. Okay, no, I don't think it was the book. Oh, okay, okay. Um, no. Yeah, because there's a. I mean, right now we're running it, and I know that I'm editing like the distance manually, but I want to see what it's actually printing, so you can see like how it looks like, right? But I don't know why I'm not seeing the serial terminal in here. It usually pops up, but not sure like why it's not here. Maybe if I make this smaller. Nope. Let me look this up. Serial terminal walk. We not appearing. Hmm. Serial print. We were doing that. Mm, I don't know why it's not showing up. Hmm. Yeah, because like this should appear, but I'm not seeing that. Maybe if I refresh this. Serial printing. Let me try printing something in here to see if it appears. Oh, I know what I forgot. I forgot the serial dot begin. I'm just remembering that. You need to set up the baud rate for your like serial terminal. In this case, baud rate it's how fast you're printing the messages. So I didn't set up that on the setup, so this was like not working. So now if I refresh these, now it should work now. Um, this is basically like saying how fast you want your messages to be printed. Um, and then, for example, in here, if I edit the distance, oh, this is so bad. Is this allowed? I don't know if this is allowed, like the concatenation. Let me remove these from here, and I'm gonna make like a new one, serial dot print, and this is gonna be serial dot println, and then distance alone in here. Let's see if that's it. Let's try it again. All right, so there we go. Yeah, I think my error in there was that I was trying to do the concatenation like, with the plus sign, but I think that's not allowed in here. So I had to divide it into two different print statements. So this one, a serial.print on the same line, and then skip line on this one, which is just the distance. And in here, if I edit the distance, then I can see how it's like, moving into different values. Remember to add this line that I completely missed. This one is to get your serial monitor started, and you can change the baud rate in here. So this is like slower than the other baud rate that was there. Okay, so let me stop the simulation. I can also share this with you if you wanna see like exactly my same setup. Because I will be moving on to something else. Um, all right, so hopefully you were able to run this example. Okay, there it is. Okay, so just to make a recap on all of the Arduino components, because now I'm going to be moving on to some complex examples of other types of controllers. Um, if you want to plug in anything, like it can be a motor, it can be an LED, it can be a switch, whatever component that you want to plug in, you will always need to declare your pins that are these ones in here. You need to do your setup just as we did with the LED. So basically say if your input is going to be, if your pin, it's going to be an output or input, and then your whole code logic, it's going to go in your loop. So you can say that pretty much this section is going to be this almost the same for all of your components. And this one is going to change a little bit depending on which component you're using. And for plugging in, basically all components have like these small letters and tells you like where to plug them in. So you should definitely just like plug in where it says like, for example, ground goes to ground, BCC goes to like the power and stuff, and then the other two pins like are digital, and you can plug them in into like any section here. We have a error in here. Got an error. Sketch Eno in function by loop. No matching function for call power serial dot begin. Serial dot begin. I think the reason why you're getting that error is because you're adding the serial begin on your loop instead of on your setup. But not sure if that's what's happening. If that's what's happening. I also shared the project code in there in case that you want to take a look. But let me know if that was the error. All right, so let us move to something different. So I'm going to show you a couple projects that are not in Arduino. I want to show you some cool stuff so you can get excited about hardware. Okay, so this one is to generate a PWM signal, but I think this one's too complex. Let me see this one. I don't like this one. I'm trying to see a project where it shows like different things so we can go over. This one might do it. I've seen my error. Okay, great that you were able to fix that. Okay, so now I'm gonna go into. We're not gonna be doing a lot of with this, but I just want to get you introduced on how this works so you can see what goes next after like mastering your Arduino. So this is a board that's called STM32, and there's different families of this board. So I'm using this one specifically, and if you see, it looks quite similar to an Arduino, but it's actually much more powerful. And you can also plug in like the same components and everything, but the thing that changes is the code. So if you're seeing, we are now coding in C, and it's not your regular C family friendly. It's a bare metal C. So actually going into like what's on the backside of all of the functions. So if I go in here into my main code, you are seeing that we need to declare exactly like literally everything. So you need to declare your input and output pins in here. For example, if we only want to configure my pin A5, so where's pin A5? I'm not sure where it is, but it should be in there somewhere. Oh, and here it is, pin A5. So if I want to configure this pin to be on output, I need to do all of these things that are in here. So first you need to reset PA5 to low, clear, and then clear the output, and then set as output. And these things that you are seeing here, these are actually masks that are shifting the beats on your operations. It might sound very confusing. I have other streams where I explain like these different masks and how they work. Um, because it's just basically I don't know how to explain this, but like you have an array of bits, and in order to declare that pin to be on output, you need to shift the specific bits according to like every specific like data sheet that's in there. So if I look like data sheet STM32, let's see just a random one. So for example, this is a data sheet, so it's like the manual for the board. If I scroll down into GPIOs, which are the input and outputs, you will see how to configure like this one specifically. So each GPIO pin can be configured by software as output, push-pull, or open drain, and they can be digital or analog or even alternate between them. Not sure why I'm not able to see like the array, because I want to see like the array of beats so you can see them and the mask. Okay, I think it's this one. Okay, mask. Mm, I'm not very happy with these results. Okay, this is what I was looking for. So yeah, let me see if there's something better. So this link is actually kind of helpful, which is a guide, STM for GPIO registers, which are your input and outputs. And in here, every board that you have, they will give you like a cheat sheet like this one, where it tells you specifically what beat goes in which position. And depending on which beats you turn on and off, it's the configuration that you're gonna be having. So let's say that like mode 00, it's like input, and then mode 01, it's output, and so on. So the thing that we're doing in here with this masking in here is that we're actually clearing the bits on that array in order to set our A5 as output. And then if I want to declare like A2 as input, I will need to be doing like all these again, but like in a different, like using different masks, because the input is different. And then these things like POOP-DR, O-type, mode-R, all of these are registers. So they're registers that we are shifting in here, that we are modifying. If you want to learn more about this, you can look up for shift registers in GPIOs. And that's just for declaring the pins. So imagine how complex it is to like read an actual ultrasonic sensor in there. It's just a mess. You also need to do like your base address of the board. This is also like a variable, your flash memory, and your GPIO base. So you want to have like a base address that you use for each pin, and each pin has a different base address. So for example, port A has this base address, which are like all of the A's that we are seeing here. But then if we move on in here and we want to use the D, then we want to change these to be a GPIO like D base, and this hexadecimal number just changes. And then another important thing, instead of just doing like your delay 10, that's actually more complex in when we talk about hardware, because you need to configure like the internal clock of the device in order for it to work, which is like this mess in here. I can show you this project if you want to see it, or maybe like ask Gemini or GPT to like explain it to you. But yeah, I don't want to overwhelm you with this. This is like really cool projects that we've done. I think I also have another project on my GitHub about a car that we built on using STM32. Uh, this one. So this one is basically a project where we made a robot that could like um, it could if you like place some points like on the floor, it could follow those points using like a camera, and instead of just doing that with an Arduino or Raspberry Pi, it's at some point an easy mode, but then when you do it with STM32, you will see that all of the code is in bare metal, and we had two cores in our STM32, so you can do multi-processing in there, and you can also do like different threading and different tasks. If you see, like, the code is really messy, like there's a lot of things going on in there. So you can also check that out on my on my on my GitHub. And if you have any questions, feel free to reach out in Discord as well. I might just stop sharing a screen on that. All right, so to be honest, I'm a really passionate person on hardware, and that's one of the main reasons why I decided to study robotics instead of computer science. I know that sometimes I do a lot of streams related to LLMs, RAG, databases, vector databases, embeddings, and all of that stuff related to AI. But then on the other side, I also like to do a lot of streams about hardware because I know that it's some things that we are usually scared about, or it's something that we don't see very commonly in our day-to-day basis or in hackathons. But I promise you that if you start learning from scratch with Arduino, you will definitely, out of curiosity, just start learning more and move forward. But yeah, it was my pleasure having you tonight. I hope that you like this stream. Again, I will be giving a stream on Sunday. It's going to be about balancing a robot. So basically, using this algorithm using PID, which is proportional, integral, and derivative. And yes, it has to do with math. And we're going to be teaching how that algorithm works and how it's related to motors. I have to say that topic is a bit more nerdy, and I think no one has ever done a stream on that. But I guess I'm gonna be the first one, and hopefully you will like it. Again, if you have any questions about your project, or you just want to learn more, or you want to build something, or you want to get started on something, feel free to reach out on Discord. I'm always available. You are always free to message me, and I will be more than happy to help you out. If you enjoyed this stream, please leave some feedback on this link that it's there. I'm also going to be sharing that on this chat. So mlh.link, Global Hack Week feedback. If you want to see something new, or if you liked something, or you're going to give us feedback in general, feel free to fill that out. And yeah, hopefully I will be seeing you all tomorrow. Thank you again for joining. And yeah, have a nice rest of the day or night. In my case, I guess so, or it can also be morning. But yeah, bye everyone.